Okay, good morning all. I think we should kick off now. Today's webinar, today's the Friday the 12th of June, it's 10 a.m. or it's about 10:05. Today's webinar is about acceptance testing. I'm giving about a 30-minute presentation this morning. My name's Gareth Jones. I'm the Managing Director of FairHeat. At the end, we will have a Q&A session. Please use the Q&A function if you have questions. Questions can be posted anonymously if you wish. Tom Norton, my colleague, will be moderating those questions. He'll give some responses as we go, but also pass those across. And Tom Burton, another colleague, is in the driving seat. So today's session is all about heat networks, and I think the starting point is to talk about why are we discussing this. Heat networks are a demonstrated model for decarbonising heat. They're pretty much the only model that we have as in the industry on a world scale, which has been demonstrated to decarbonise heat on a large scale. Obviously, heat pumps are part of the solution, but we see those as being in conjunction with heat networks. The slides that we're showing here show from Sweden a growth in district heating between 1969 and 2015 over time, and on the right shows a drop over the same period in the carbon intensity of the heat delivered. As we can see, effectively a total decarbonisation of heat over that time, down to very low levels. So there's a very good reason why we want to have heat networks and why we've embarked on that in the UK. It's a relatively recent journey for us, starting probably really only seriously over the last 10 years, although there's quite a long history of it, but we picked it up again over the last 10 years and driven forward. And what we've seen, unfortunately, is going back 2015, we did a piece of research with BASE with Guru Systems as part of an SBRI project, and as part of that project we reviewed 30 different heat networks in the UK and looked at the performance of those heat networks. Heat networks effectively is about transferring heat from the point of generation through to the point of use, and a really good way of measuring how well those heat networks are performing and performance for those heat networks is the losses you get from them. In this case, these are residential schemes, and a really good way of measuring that is to look at what are your losses between point of generation and delivery per dwelling. And when we had a look, what we found is that this shows the number of schemes we had by losses, so it's a histogram. And what we saw is that although the most schemes were in the there were a chunk of schemes in the 200 to 300 watts losses. Actually, we were seeing losses right through to 1,000 watts per dwelling, which is a kilowatt per dwelling, standing losses from the system. And what's good performance, or what we'd sort of be expecting, if you look at CP1, so the Code of Practice 2020 that's coming out now, they're using this metric of watts per dwelling, and that sets out a minimum requirement of 100 watts per dwelling. So we're seeing a very big difference between actually what's a minimum requirement, it should be a minimum requirement, and what there was in practice. Indeed, when we had a look and saw what we thought when we went through and did analysis of what the potential losses per dwelling were, we saw that the potential losses per dwelling were around about 70 watts per dwelling, whereas we were seeing an average of 500 watts per dwelling in the actual homes in the schemes we were looking at. And when we investigated that further, we saw that that was driven by two things. It was driven both by design, so oversight, so pipe sizing, selection of insulation, length of network, type of equipment installed, bypasses, for example, and the other one was installation and commissioning, so how well the systems were actually realised and commissioned. With about half and half, or a bit more than half, being on design side, so about 57% from what we saw, and the other half being, or 43% being from the commissioning, install and commissioning. And when we took a look at that and investigated further into it, what we saw in these schemes, so this is back from 2015, was the performance of the HIUs, so the heat interface unit within each of the dwellings. and the actual dwelling performance, so how the tertiary systems are set up within the dwelling, so the heating circuit within the dwelling and the domestic hot water, how that was set up was a really key impact on the performance. In fact, when we had a look at it, talking to most people and looking at these schemes, quite often when we're speaking to people are saying, look, we've done a lot of working, we've gone and looked at the performance, we looked at the performance of the plant room, and this is the way people tended to talk. They talked about plant room, the energy centre, then they talked about the network, and then finally they had some thoughts about the dwelling. When you look at a heat network and look at the performance hierarchy of importance of performance, so the impacts on performance of a heat network, that's totally the wrong way around. If you look at a communal heat network, by far the most important piece is the dwelling. You start there, then you have the communal heat network, and then you've got plant room. Very similar for a district heating network. It's all about the dwelling, then the communal network, then the substation if you've got a connection to a larger district heating network, then district heating network, then the energy centre. And what we've seen is that in terms of the way people look at this, they quite often look at the other way around. And half of FairHeat's business is actually looking at performance of existing heat networks. And what we really need to focus on every time we go into those is performance at the dwelling and then sub-network level. And as part of the original study we did back in 2015 through 2016, this is a really good example that illustrates. This is showing the performance of a heat network where we went and mapped losses of the network overall by flat, by component. So this is showing the total losses in kilowatt hours per annum. So in this case, this is actually one of the better performing schemes. So we had on that histogram, so the mid to better level, we had about 2,700 kilowatt hours of losses from the network per year. And where we went through and had a look at where those losses were occurring, actually most of the losses, 71% of those losses, were in the final connection from the corridor through to the dwelling in the HIU, with the other 30%, roughly 29%, inflow and return pipe work. And with about equal losses, which you'd hope not to see. You'd want to see much higher losses on your flow pipe work than your return pipe work. But from all the rest of the networks, that's plant, laterals, risers. When we went through on that project, what we did is we actually went through and said, oh, what happens if we were to recommission the whole system and set it up as it should have been? And this is what happened. So what we went through and had a look at is, what can we do? So we put in some additional insulation on the final drops downs to the HIU, which should have been there. So this is install issues. There were problems with how the network had been commissioned, which actually damaged valves in the HIUs. We replaced those. We went through and made sure that domestic hot water and space heating were set up properly. And we did a number of other adjustments on the network. And what we saw is that we could get those losses from that 2,700 down to about 850. So that's about a 70% reduction. And these were actual interventions post installation. And that comes out to roughly that sort of 100 watts, a bit under that 100 watts per dwelling. So that shows that, coming back again, the sort of driver that gets us down to 1 point in terms of that's all from the commissioning issues. The issue is, and part of our study that we're looking at, is what's driving it? And can you look at data and then work out what's going on? This here shows dwelling level HIU performance. So this is performance from a dwelling, and the blue line up top is the space heating temperature, so it's sitting there about 70 degrees just above. The green line is showing return temperature, and what you'd really hope to see is that was much lower than the flow temperature. This is in individual dwelling, and the light blue down bottom, sort of aquamarine, is the flow rate. And what you see is you've got constant flow going through into this dwelling, even when it's not being used, with these little jagged down pieces, which are being the return temperature dropping when you've got use. Problem is, you look at this and you say, well, is this a problem with the HIU itself, or is it a problem with how it's being commissioned? And if you just look at the data, it's very hard to tell that if you don't know anything about what equipment's been installed and how that equipment's supposed to perform. In reality, in this case, this was actually taken just the other day. This is actually a very good HIU that's been poorly commissioned. And that shows why you need to make sure that things are commissioned correctly. So coming out of the SBRI project, there are two separate initiatives that FairHeat undertook. One of those was to develop an HIU test standard, which we did, and then we've got BESA to adopt as it's become an HIU test standard for the UK, and then the other was acceptance testing. In terms of the BESA HIU test standard, what that does, it's a test standard for the UK. If you are procuring HIUs, we would really strongly recommend to make sure it has been tested. And what the test does is provides data on comparative performance between different HIUs in different modes of operation, whether that be domestic hot water, space heating, standby, in typical UK conditions. And it allows comparison between those HIUs, which allows you to then evaluate, is the performance we're seeing in reality, in real life performance, what we should be seeing given that type of HIU. The other piece that we developed was looking at acceptance testing and how do you ensure that what's been installed and how the system's being commissioned actually meets design parameters. That's all fitting into an overall delivery process, and if you come back to the Code of Practice, Heat Networks Code of Practice, this is that stage which looks at actually how do you make sure that we've got a system being commissioned correctly. So in terms of what FairHeat does, if we go from end to end, the specification stage where we should be looking at what are the practical decisions that we're making, what are the parameters we're setting up for your heat network. Then you've got design. We look at actually, has this design been optimized? Will it meet those design parameters and KPIs we've set out in the specification? You then look at install. Is the system being installed as it should be, as per design and good workmanship? Commissioning, what's the method statements? How are you actually commissioning the system? And then going through and identifying that. And then the final bit, well, this piece here is testing before it goes into operation. And it's really making sure that you're testing the system to ensure that performance requirements are being met through rigorous independent testing. And that's this acceptance testing piece. If we look at the process, there are really 4 steps in process. The first is make sure you establish what the acceptance testing criteria are. You then flow on to initial acceptance testing, which we'll come into. You go on to the testing regime itself, and then at the end you go through and do a certification process. And that's going to become more and more important, which we'll come to talk on further as we move into regulation of the heat network sector. So going through those, establishing the acceptance testing criteria, it's really important. At the start, you sit down, it's a collaborative process, you look at the design, you set out the key KPIs from that design, and then you make sure that the client, the designer, and the contractor all sign off on those criteria of what the design is and what needs to be met in order to come back and determine that design has been met. Then we go into initial acceptance testing. That's a really important process. We've put 10 dwellings there. The idea is that before you go through and start doing a large rollout across your scheme, ideally you do it as a pilot, where you go through, you set up and you install all the equipment that should be set up within a dwelling. You go through and then commission those dwellings. And then what we do is we come in, we'll go through and test all the different elements of performance and look at the different ways the system could be utilised by a resident, whether or not that's whacking your thermostat on max and then switch just using your TRVs to control heating, all the things that people would likely to do. And what we look to see is what are the systemic issues that might be in place? What are there issues with how different elements of equipment are working together? And then once we've identified those issues, then we work with the client, the designer, the contractor to determine pragmatic solutions. How are we going to resolve that? Quite often that then results in having to change some of the criteria. It's really important in part of this process that there's sign off on those criteria and approach if it's required. Once that's done, you make sure that all of those dwellings are then are adjusted, you retest, you demonstrate that they now meet those criteria, and then roll out to the rest of the dwelling. If we look at going through what sort of potential systemic issues you might see, I don't think there's been a single, well, there hasn't been a single site that we've worked on where we haven't identified some systemic issues. And there are a large number of those. Some of those might be really simple. So domestic, setting your domestic hot water temperatures or space heating temperatures, setting those incorrectly. So that's more of a training issue. There might be other issues. So for example, reference radiators. It's really important on every system where you've got an HIU that if there's a call for heat, you have one HIU that is not closed. So you have some flow through that. Quite often what we'll find is that that reference radiator can be actually switched off, and then you get a conflict where you've got a call for heat, the system comes on, the HIU comes on, it tries delivering heat, the pump's on, but there's no way of actually delivering heat because that reference radiator is closed. The residents put the thermostat up to max, and what you get is a bypass back onto the system. Now, sometimes that might actually just be a simple cap, and you can make an adjustment to the cap. There might be other ways to deal with that. The really important thing is that all of those get dealt with before you then go into acceptance testing itself. So the next piece I'm going to talk about is actually what's acceptance testing about. So in acceptance testing, we test performance at a dwelling level. We then go through, if there are any issues, identify, then the contractor goes through and rectifies those issues, and then we get retesting, retest, and then ideally you get certification that it's met, every dwelling's met the requirements, or if not, you might get a conditional pass, and you issue a certificate with the test results. And you do that on 100% of the dwellings. One of the things that's really important is right from the outset, we talked about the design parameters and testing parameters. It's really important that those are very clear, and we try to make sure that you can fit all the testing parameters onto a single sheet that your contractor or your subcontractor can have on site when they're going through commissioning. And it sets out for all the different settings or different modes of operation, whether that be standby cold water delivery, domestic hot water, space heating, what those parameters are, what the design value is, and then what the acceptance thresholds are. So that might have a lower bound and an upper bound, or in some cases it might just have one or the other, and the rationale behind that. The actual process itself is non-invasive, so it's a non-invasive testing process, really important. So we don't go through and actually make any adjustments to the system itself. That's really important from a contractor's perspective, that we're not making changes to the system itself. But it's also going through and just testing it as though a resident might be going through and using that system. So what we've got here are a couple of our engineers. Tom Burton, who's driving, is third along. And this is just showing the sort of test we carry out in the flat. The acceptance testing profile itself is really clear, and this actually shows a test for a dwelling that's passed. So what we've got here is the blue line up top is the flow temperature into the HIU from the network. The green line shows the return temperature, and then the yellow line shows the power. And this is from Guru Pinpoint, which gives us 5-minute data, and we use a lot when we're going through and doing this sort of testing, because it gives you a really clear visual on performance. And what we can see here is that good performance is really clearly visible. So what we've got is we've got a first period of standby and the last period of standby. That's when the system isn't being used, and it's in something called keep warm. So you've just, in this case, it's a trickle bypass going through the HIU. It can be a different profile from an electronic HIU, which would just be, you'd see a little flicks up over time where it's letting pulses of hot water through. But in this case, we've got a standby flow temperature of 40 degrees, a return temperature of 32 degrees during that period. We've then got domestic hot water period. So you can see someone's gone and switched on the tap. That's actually Tom Norton, who went and did this back then. And we can see this is the middle of summer, so we've got quite high cold water delivery temperatures to the site. But even despite that, we've got a 22 degree cold water return, domestic hot water return temperature. And you can see that you've got the flow temperatures sort of jumped up at that point. So this was the 75 degree heat network. You've then got your return temperature on your, you've got space heating, and you've got that initial spike of power going through the radiators, and then it settles down to quite a steady 2 kilowatts, which is the sort of performance that we'd normally see, the sort of heat demand we'd normally see. And you can see a return temperature of 43 degrees back from that heat network. In this case, you've got a 60 degree flow, 40 degree return on those radiators. So that's quite good performance. So what you can see here is that actually that's really good performance, that passes, and we've got all the results. Poor performance is also really clearly obvious. So in this case, we've got the big change here is if we look at standby, we've got a 64 degree flow temperature with a 60 degree return temperature. What that means is all of that pipe work going into the dwelling is being kept warm. That means higher losses, and it can also lead to things like overheating. And you can see a domestic hot return temperature there, domestic hot water return temperature is 30 degrees rather than 22 that we saw earlier. This here is simply because the domestic hot water set point was set incorrectly. Very easy to deal with if you pick it up before the resident goes into the dwelling. So the key point here is that we go through, we make sure you've got this little window of opportunity after a system's being commissioned before the dwellings are occupied to go through and make sure actually it's performing as designed, and to go and pick any commissioning issues and get those dealt with. Acceptance testing itself is now a really well-established process. We've got 34 developments overall where we've carried out or carrying out acceptance testing. Some of those are very large, so they're over a number of years where we're continuing to carry out testing as different phases come through. We've got 12 different client organisations who have specified acceptance testing. Almost all of those are specifying 100% acceptance testing. And to date, we've gone through and tested 4,700 dwellings. As part of that process, what we're also trying to do is make sure that we're trying to make it as smooth and seamless as possible and build in with contractor and developer processes to make sure we're not interrupting that overall handover flow. As part of that, we've been trying to speed up the process and we've helped develop, working with Guru Systems, a product called Guru Verify. There was funding from BASE to help develop this, which is an app which really allows improved transparency, speed and cost effectiveness for new heat networks, where it's an app. You can go in, it's very quick to go through, you take photographic evidence as you go in, and that's tagged to every dwelling. And it's also a process that allows contractors to go through from the outset and check their own work at the outset to see if it's likely to comply. Really importantly, there are two parts to the app. I won't go into a lot of detail because I'm aware there's another webinar coming up on this that Guru's running. But effectively, we get test results, and those test results from the application are directly visible on a web portal. So the client, the developer, can actually see those come through, but really importantly, so can the contractor, so that as each dwelling is tested, they can see the results and then quickly go back and resolve any issues there might be. With the key outcome of all of this being a certificate. So we issue a certificate setting out performance, setting out all of the details on how the system performed on every dwelling, and then giving a certificate against performance, which is really crucial. We're coming up soon. I think most people will be aware that that BASE has just run through a market framework heat network consultation, and as part of that, they flagged that there's likely to be certification requirements and minimum technical requirements for schemes coming through. So what we're trying to do is, in anticipation of that, actually set up certification of schemes so that we can get the market used to compliance and actually being certificated against compliance, against performance. And I think the really critical piece is that we've demonstrated that through acceptance testing, you can actually get really good performance. This is a scheme from the Guinness Partnership, Quayside Totnes, which is back, so this is actually back from 2018. And this is where we're starting to see the sort of the fourth generation performance coming through. So these low temperature heat networks coming through, which is really important for decarbonising heat and starting to introduce heat pumps into heat networks. So this is showing, the blue line there is showing consistent 60 degrees or just under 60 degrees. And this is actual performance of around about 30, just over 30 degrees. So I think on average that site was operating at about 2 degree return temperature. So that was back then, but that's not just a one-off. This is just on a consistent basis. So this is another scheme, which was Northolt Road. This was back from January. And this again, we're just trying to drop those temperatures even further. So this is the block level. This shows return temperature, flow temperatures of around about 56 degrees. So we're trying to get down to that 55-degree flow temperature, and return temperatures in that sort of 30-degree realm. And this is in the middle of winter, but not just in the middle of winter. It's on a consistent basis. And the really important thing here, we're going back again to that gap, performance gap we're seeing at the start, where we're talking about over 500 watts of losses coming down to 70 watts of losses, which was the target and what we should be achievable. Actually, this scheme here is achieving below 70 watts losses per dwelling. We now think we can actually get down lower than that to 40 to 50 watts per dwelling, which we put in context. That's actually significantly less than you'd normally get from a hot water cylinder under the old sort of traditional schemes. Not just that we're seeing really good performance, really importantly, we're also seeing as a result excellent reliability and resident outcomes. Guinness Partnership was kind enough to share this data. They didn't want to name the scheme, understandably, but this on the left is showing the repairs recorded on very similar schemes, one which had gone through via traditional methods, hadn't had any acceptance testing, which is scheme 1, and Totnes. And what we're seeing there is we're seeing almost 90 repairs recorded in 1 year at this other scheme over a course of a year, whereas Totnes had 1 callback and repair over the course of that year in 2019. So that's actually significantly after we've gone through the acceptance testing process. And the quote on the right, I'm going to read out because I think it's really important, because it's resident outcomes that is critical to this. This is from Claire Taylor, who's the Housing and Care Manager at Quayside Totnes. And she said, since the scheme's opened, the heating system has been fabulous. Residents regularly tell me that they've never had such low heating bills. It's a wonderful system for ensuring the well-being of our residents. And ultimately, that's what we're trying to do this for. And I think this is where we come to the benefits of acceptance testing. From a client perspective, if you specify acceptance testing, then what you're really ensuring is that you're getting a network and dwellings which are performing as per design, and you're getting a large reduction in return visits and call-outs. That's really important from a cost perspective, but also in terms of having happy residents. From a designer perspective, from design consultants, you're getting the knowledge that design intent has been achieved. And also you're getting data back and feedback into future designs and looking at actually what can we do to tweak our designs going forward if there are any issues coming up. From a contractor, you're also getting that feedback, but you're getting upskilling because you're getting direct feedback to your staff on their commissioning, and you're getting reduced revisits and call out, and you're getting a basis to actually show data and to clients to win future work. And then in terms of residents, you're getting systems that actually work, reduced overheating, which is a critical issue, cheaper bills, and better reliability. Something I think a number of people on the call are going to be interested in is the fact that acceptance testing is going to be part of CP1 2020 when that gets released later this year. I sit on the steering group of CP1. They've already flagged there's been consultation showing that in CP1 2020, acceptance testing is going to be a minimum requirement. There was actually quite a lot of debate during in steering group, whether about roughly 50-50 split, about whether or not you should have 100% independent testing, acceptance testing as minimum requirement. In the end, it was made a best practice, but the minimum requirement is that 10% of all initial dwellings are to be independently tested. If any of those fail, so any failure, then you have to have an additional 10% tested until you're getting a full set of 10% passing. Then following that, you need an additional 10% being random testing. And if any of those 10% fail, then you need to add another 10% on until you get to 0% failing. So it's quite a significant amount of acceptance testing being required. And that's likely to come in from later this year. When we're not exactly sure when it's going to be released, but as soon as CP1's released, that will be in as a minimum requirement. So take-home points. I think first is that excellent heat network performance is achievable. If you go through your process well, you make sure your schemes are designed well, and then you check your commissioning, you can do it. Acceptance testing is essential to that process. And it's really important for good network performance and resident satisfaction. But it requires a really rigorous process-based approach. Don't think you can just say, okay, we've got these targets and then we can go measure them. It's really important to go through a process with all the different parties and work in collaboration, and that collaboration is key. And final one is that acceptance testing is now part of CIBSE ADE Heat Networks Code of Practice, will be as soon as that's released. So finally, acceptance test improving performance. This was actually from Tuesday. I just wanted to show, so the last slide was back from the middle of winter. This is earlier this week. We're getting those, just under 60-degree flow temperatures, 26 in this case. It sits a little bit below 30 degrees pretty much consistently, the return temperatures on that network. So that's all we've got there. I think we're going to come on to Q&A now. Tom Norton and Tom Burton.
Thank you, Gareth. Can you hear me?
Yeah, I can.
Excellent. I've unmuted. Okay, we've had some great questions during your talk. We've got 9 in total. So first of all, good question about contractors. So how do contractors normally react to this process? Because we'll be scrutinising their work and asking them to carry out additional works. So do we get pushback from contractors?
Yes, I think is the simple answer. I think initially we've seen quite a big change at the start when we started with it, and sometimes when we start with a new contractor, we see some initial pushback. What I think we've seen over time, and particularly as we go through on individual sites, is that the contractors we work with very quickly see the benefits to them, and we now have contractors who we've worked with on a number of different developments who are actually really positive with it and see it as being a positive addition to their processes and have incorporated it in. So I think there's been, initially sometimes we see quite a lot of pushback, but then over time actually it becomes quite a collaborative process, and I think they see it welcoming. We've had some contractors have actually suggested it to clients on other schemes and have asked for us to be brought in as part of the process.
Mm-hmm. I mean, I'd as well, not being a contractor, but the impression I get is that contractors like certainty, and that's one thing that this gives. It gives it's a clear, there's a certificate, there's a clear outcome, and it's understood by all parties when something has been completed. So yeah, that's another benefit. Is there a trade-off to be made between system efficiency and resident satisfaction or experience? Good question.
That's a really good question. I actually think that the two go hand in hand. The best schemes that we have seen end up having better performance, having better outcomes for residents. And the way that tends to manifest itself is if your scheme is well designed and is a very efficient network, then it tends to actually also be much better reliability. Your temperatures will tend to be lower, particularly on the return temperatures, and we would argue on the flow temperatures, which means you're getting lower losses, which means you're not getting overheating. In fact, this is going to have, it's going to be about the lowest overheat, lowest heat gain into a building of any system that you can think about will be a heat network. And then finally, I think the big area will be on delivery times, for example, for hot water and temperatures. And I think that's where, also space heating temperatures, I think that's where you could look at being some potential trade-off. I don't actually think it needs to be a trade-off. I think if you design your system well, then it certainly won't be a trade-off, and you should be. This is part of, there's a CIBSE domestic hot water working group at the moment, and that's part of the key question is how do we make sure that we get good resident outcomes, and we design for good resident outcomes. And Tom, do you have anything to add to that?
No, I think that's pretty Yeah, I think, like you say, if the system's designed well, commissioned well, and performs as intended, then that usually provides the best customer experience. Okay. Again, I suppose related to contractors, or the contractor-client relationship, how do you deal with issues when you can't get a dwelling to pass on all dimensions?
That's another one that comes up. You need to be pragmatic sometimes. I think the key point is to engage the client, the design consultant, and I think everyone needs to be involved in those decisions. Sometimes there needs to be some trade-off made. So, for example, if you can't get delivery time and domestic hot water through to a resident, then there's going to need to be some decision made at that point. So the options would be, do we rip out take down the ceilings and change all the pipework? That's likely to be, unless you've got an incredibly long delivery times, that's likely to be, well, that's going to be the ultimate one you go to. That's the last one you would want to go to. So then there's going to need to be some sort of trade-off between, okay, do we look at flow rates and perhaps we up the flow rate at a particular tap, and let's look at that, versus do you accept, rather than being 45 seconds, being 50 seconds on a particular outlet? And in those cases, I think what tends to happen is you get an agreement and then you get a conditional pass. Or there might be other elements where, again, you actually go, rather than being a green or red, you might actually signal something up as an amber. And then some of that cases, that actually might be a latent defect that's flagged, but it's actually a conditional pass where it's passed. But that's, again, goes on to certificate.
Great. How do you deal with issues? Do you see much variance in testing heating? This is a very good question, very technical, especially as fabric heat loss design conditions are very unlikely to be present when testing is carried out and will vary between site visits. I think that goes back to our mid-August testing of heating systems. And how do you actually properly evaluate them?
Do you want to start off on that, Tom?
So it definitely is a challenge. I'd say it's not so much about the external conditions. It's about what the conditions are within the flat. So as long as the temperature internally within the dwellings is 20 degrees or below, then that shouldn't affect things. It'll shorten the heating time because the flat will obviously get up to temperature very quickly. But there are obviously times when the temperatures are above 20 degrees. In those cases, it goes back probably to the previous question. As long as everyone's open and clear about it within the teams, between the contractor, the client, ourselves, the consultant, then you can be pragmatic about that approach, about what temperatures you will accept. Also, with the introduction, and again, this is a CP1 compliant with the introduction of flow limiting TRVs, it can be it becomes more a case of making sure that those are commissioned correctly. And if you have, if you've commissioned each radiator to the correct flow rate, then maybe you won't be getting those temperatures in mid-August, but you can have a fair amount of confidence that those will be met during the winter months. Would you have anything to add to that?
Yeah, I think the one point I would add is, if a system has been, radiators, for example, have been well balanced, then you will get, the key point is to make sure you're getting heating to every one of those dwellings. To every one of those radiators, and you're getting that consistently across all radiators, and you don't have any cold radiators. And then you can actually go through and do some calculation of what the expected return temperature would be if your dwelling is at 23 or 24 or 25 degrees. Then you can go through and calculate and have some estimate of what those return temperatures would be. But again, coming back to your point, Tom, I think the flow rate point is really important.
Okay, what's stopping a maintenance contractor adjusting the system subsequent to a pass certificate being provided for that system?
The answer is nothing, unfortunately, and that's something that's really important to sit on top of. That's why we would argue that you should be using data and sitting on top of the data and checking the performance on an ongoing basis, and why you need to have very good performance KPIs in your contract, your maintenance contract, and be measuring those and identifying where the contractor's gone through and made those changes, and very quickly picking those up and going back and rectifying.
Mm-hmm. I'd say generally as well, there's very little incentive for them to do that, because once they've carried out the commissioning correctly, then they have a system that's working very well. But yes, if we have data, then we can see, we can see through the whole process and post occupancy how the system's performing.
I mean, Tom, I guess the one issue around that might be, for example, someone's not used, and this is where you come up to resident education as well, someone's not used to lower temperature radiators, makes a complaint that their radiator's not hot enough, and because they put them on every morning for an hour to come on or 2 hours to come on and then go off, and they complain about not being hot enough, and then you get a maintenance contractor who comes in and basically, just to deal with the issue then and there, they turn the space heating temperature right up to, and then that creates a bypass onto the network. And I think that's where education of both residents and contractors is really important.
Okay, I'm conscious of time, so I'm going to speed up a bit. I think we'll stick around anyway till all the questions are answered, but I'm conscious that people will have other meetings to go to. So question from Dave, are there any dwelling related issues that won't be picked up by the tests you carry out?
There will be dwelling related, there potentially could be dwelling related issues. For example, if we won't be picking up issues to do with the material or the fabric of the dwelling itself, heat losses from the fabric. We will tend to pick up, for example, things like the radiators being installed back to front. Unfortunately, we see that quite often, or taps being installed the wrong way around, so hot to cold and vice versa, or the thermostat not having batteries in. There are quite a few of those sort of issues which aren't necessarily to do with the heating system or district heating system that will be picked up. Obviously, there will be other snagging issues which this doesn't deal with. This is all around the heating and hot water and domestic hot and the coolings. The cold water systems, and also if there is cooling, we will be picking up those issues as well.
Okay. Does acceptance testing just apply to flat performance? So we've just spoken about dwellings really today. Can it also be applied to plant room, and an extension of that, I suppose, to block level performance?
Actually, yeah, that's very well picked up. We should have, acceptance testing itself it's a cascade. You deal with the dwelling first, you then, once you've gone through all the dwellings, then absolutely right, you do block level. We do load testing across the whole blocks, look at performance at a block level, and then do certification at block level. And then as your system comes through, then you come through to the overall network, and then to the plant room itself. Sometimes that might actually span multiple years. So you're starting off, so you'll be bringing through dwellings and blocks and then doing certification over time. So yeah, very good point. And it does extend beyond dwelling to blocks into whole network.
Okay. In what circumstances would you recommend doing the 10% plus 10%, so the minimum requirements in CP1, as opposed to just testing 100% of the dwellings as per the best practice?
For me personally, never. I think there was a lot of debate about this on the steering group for very good reasons. Some people were concerned that it might add cost in. Most of the clients we've dealt with who've been through the process have actually understood that it saves cost because you don't have callbacks, so you get significant savings. And the real issue is, so I showed that HIU before that we had really poor performance. That's actually a really good HIU. You only need a few of those on your network to really muck up your performance, and that can have big losses. So I would argue you should always go to 100% acceptance testing, unless you disagree with that, Tom.
Nope, absolutely not. Have you done much work on retrofit schemes, i.e. where a heat network is replacing other heating solutions? I mean, I think
you should answer this one.
Yeah, I mean, so we have done a lot of work on retrofit schemes, and we do apply all the principles of acceptance testing there. So once work has been done, then we'll carry out extensive testing, which will typically be around the acceptance testing procedures. It can be slightly difficult if properties are still occupied. That might affect the testing you can carry out, but I would say definitely it's a very, very useful tool for retrofitting as well. Anything to add?
No, that's all fine.
Okay. We have what are the most common issues observed when commissioning? I think you covered that really, haven't you, with the slides? Yeah. So if we go to the next one, question from Manoj. Excellent work. Okay, so I'm definitely going to ask this question. Long overdue for the heat network industry, but given the looming SAP 10.1, developers are already gearing up for indwelling heat pumps. For CO2 reasons, not having something similar, i.e. acceptance testing for those, will it unintentionally promote use of those indwelling heat pumps compared to HIUs?
Yeah, yes, we don't have that long on this call, but we could spend a lot of time on this. I think first point to make is indwelling heat pumps. I think there are a couple of different scenarios there. I think we're talking about individual heat pumps versus the sort of so-called ambient loop with heat pumps within dwellings versus heat network. I think the first point we would make is that we should have heat pumps. They are an important part of the landscape going forward. In urban settings, we would see that we should be looking at fourth generation heat networks within buildings. But then wider area, there may be cases where actually ambient loop does make sense on a wider scale, where you can get sharing of heat between buildings, or you've got very good low carbon sources. I think so low temperature heat locally. I think our answer would be that you should be doing this sort of testing no matter the dwelling. We are doing testing on systems with ambient loops and indwelling heat pumps. Where you're going to individual heat pumps, it's a very good point, and I think it's entirely right that I think what we're seeing in the industry as a whole is there have been historically very significant problems. Traditional gas boilers in dwellings, we've gone in and found that half of the radiators installed in most sites we go to, this is with an individual gas boiler, are back to front. There's a big issue with commissioning in this country, and I think going forward, it's something which people should be, and BEIS in particular and others should be looking at, is how do we ensure that where we don't have heat networks, that residents' interests are protected, and there should be something very similar, I think, with a sort of acceptance testing process. Do you have anything to add to that, Tom?
No, I agree with that. I think most, if not all of the testing that we do about the heating system, about the hot water system is, one, it's about the resident expectations and comfort. So I think that's completely the same. Also, ambient systems or heat pumps, some of that does rely on low return temperatures from space heating systems. So if you've got radiators that are unbalanced, even low temperature radiators are unbalanced, that can cause problems as well. So I think there's the vast majority of the testing that we do is crosses the boundary into sort of ambient loop systems as well. Okay, three questions left. Would we suggest a minimum sampling rate from meters to ensure a good level of commissioning and monitoring?
I think the higher sampling rate you have, the better. 5-minute data compared to 15 minute to 30 I think we see a significant difference. There are certain elements, there are certain things that you'll miss on half-hour data that you just won't pick up, particularly with, you might see issues post-heating where heating's coming on and off. We might get a little bypass for a period and it goes through. I would definitely recommend 5-minute sampling. If we could go to 1 minute, that'd be brilliant. I think 5 minutes is quick enough. Mm-hmm. Tom, you're?
I think it's obviously the higher the frequency, the better, and then it becomes a case of diminishing returns. So as you get higher and higher frequency, the difference between 5 minutes and 1 minute is not as great as difference between 30 minutes and 5 minutes. But yeah, the higher the frequency, the better. And also it's worth pointing out that a lot of the acceptance testing is visual and observation based as well, to that as well. Okay, so a question from Alistair. Guru Pinpoint gives you a lot of data. What impact does it have on the process where there's no inbuilt monitoring system in the flat?
It's a really interesting one. As Tom was mentioning earlier, a lot of the testing is visual and there is a lot you can do. We do find, however, that where we don't have really good data back, the outcomes tend to be a lot worse. And there's part of that is actually everyone's aware that you do have data and where you can visually go in. And if you have contractors who go through and do an installation and say, actually, my HIU, we've done it, and you can just go onto the network and look at it before you go and say, actually, no, you haven't gone and commissioned. We can see that you haven't commissioned, then it makes a really big change and the mentality change quite significantly. So I think it is quite important to have data. I think it's really, really hard to get good results when you don't. There are definitely, you can get a certain way, but you're going to get some benefits, but you're not going to get a lot of them if you don't have the data.
Okay, final question from Marco. Hello, Marco.
Hello, Marco.
At what point is acceptance testing undertaken? Often the mechanical works progress ahead of the electrical comms works. The HIU is on the wall and wanting to be commissioned before the tertiary systems within the property are to be commissioned, or the HIU is on the wall and wanting to be commissioned before there is any remote internet activity to the site. How do you deal with this? I think it's probably related to this previous answer.
Mm-hmm. I think it's a really good question. One of the key, I think it comes back to that collaboration as key point earlier. What we've found is that when we have been working with certain contractors, the key point is comms and starting off the comms really early, right early on, being very, very clear on timings, scheduling, making sure that you have equipment installed at the right times. If you don't have comms in place, for example, the ADSL issue, then you get mobile comms in. Where you don't have that, then you can still extract data locally. And I think that's the really key point there. And just being very clear on actually what's required to be able to go and do testing at that point. Yes, there needs to be some pragmatism around it, but we find that there is a way through it and that you certainly can get the point where you go in and make sure that you've got the system set up that you can go through and test, and the programming is really important, but it's a good point.
Yeah, I mean, I would say that it kind of emphasizes that this needs to be a collaborative process between all the parties. So, at the very beginning of the project, as soon as the contractor's brought on board, that is a meeting that you should be having with the consultant, the contractor, the client. Everyone's sitting around the table. It should be clear what the milestones are, what things need to be in place at what time. Now, in reality, you'll know that might, nothing's perfect and that might not happen. But as long as we're open and communicate as much as possible, then we do find, quite a lot of the time there's quite good outcomes and things do align quite well for the testing. Okay, that's we're about 11 o'clock now, so apologies to anyone who asked a question that we couldn't get to, but thank you for all the excellent questions, very thought-provoking, and I'll hand over to you, Gareth, just to finish off the presentation.
Yep. thank you all for coming on, much appreciated. We are looking to do a series on heat networks and achieving good performance. This is a first of a number. We might repeat this one. If anyone's got any burning issues or things that they would like to go on that us to go through and talk about, then please send through emails and we'll do our best to accommodate and set things up around that. And I think the final point is please just be aware this is coming through. Acceptance testing is coming in later this year. If you've got networks coming through, then it's probably time to start thinking now about how you're going to accommodate this new requirement. And we would certainly be very happy to talk to anyone about acceptance testing and how to include it into your processes. One final piece, Tom, can you bring up, there's a upcoming webinar that's on the Guru Verify system, which Guru's running. It's something that FairHeat developed together with Guru, and it's a way, what we're trying to do is make sure that we make this whole process a lot more streamlined and slicker going forward. So that's on Tuesday, 30th June from 11 to 11:30. So just thought I'd let everyone know that that's coming up. Thank you all for your time, and I hope to speak to many of you soon.